Hello developers, let's start developing. My name is Veko and today we'll be solving the 11th problem of Advent of Code. Once more, I have taken a sneak peek at the task, but I didn't attempt any kind of solution yet. Seems that we have a cavern again and we have something that's called the dumb octopus, which is apparently a thing. Yeah, it looks like the dumb of the elephant, but it's actually an octopus. Okay, what we have is we have a 10 by 10 matrix of them, 10 by 10 grid, and they flash somehow. They have some kind of an energy level, and once that energy level goes up to 9, they emit a flash and they go revert back to 0. Now the issue is that we have some kind of a weird scenario that when it flashes, this increases the energy level of all adjacent octopuses by 1, including octopuses that are diagonally adjacent. So that means that we have 8 neighbors for each of the octopuses. So if this causes an octopus to have an energy level greater than 9, it also flashes. Okay. And any octopus can flash at most once per step. Finally, any octopus that flash during the step has its energy level set to 0 as it used. So we have this scenario, and the flashes, the energy increasing is incremental, so to say. So if we have this step after the first, between the steps, so what is the step? Actually, this one will flash increasing, this one will flash increasing one, this one will flash. So we have 8 octopuses that will flash, this will become a 9 and it will flash itself. So I think that is actually, yeah, so in the meantime this will become 10 actually, and only 10 flashes. So this here the octopus doesn't flash, but it will flash on this step. And the initial thingy doesn't have a 9. Let's see if our input, and this time basically we will have the more or less the same format of the input as we had in the example, because yeah, there are no 9s and it's a simple 10 by 10 matrix. So I think that once we solve the initial case, the solution will be basically identical for our own. It's not the same because we have 548 and we have 572 here, but I guess it will be similar enough. Okay, let's start with reading the input. So the input will not be a number array as I have it as a default, it will be a number array. So let's just fix that. Yeah, so this works. What we need to do is we need to read our input, and then we need to map them, we need to split, and then whatever we split we actually need to map once more into a number. I don't like this. So that's a single character that we will get to map as a number, and we just need to return the lines, which, if I'm not mistaken, yeah, that's a matrix of numbers. Let's run this in debug mode so to see whether we are getting our input correctly. Yep. 1 2 3 4 Let's just take a look at it like this so that we can count 1, 2, 3, 4, 5, 7, 8, 9. I guess 10. 1, 2, 3, 4, 5. Come on. Well, we are developers. Why are we counting the input? Show me the length. Yeah, it's 10 rows of 10 numbers each. So, let's have this. We were gonna need a helper method. Execute step. And this will actually take a grid of octopi. I have no idea what is the plural of octopus. It could be octopi, it could be octopuses, it could be octopodi. I have no idea. But let's just say that we have a grid that is a number array, and we are also returning a number array. So what the sense of this method is, that basically yeah, something like this. We're gonna need to take a grid and return a grid. So we're executing a single step. I'm gonna copy my expansion idea from few days back. So what we're gonna do, we are getting a 10 by 10 grid and we're gonna replace that with a 12 by 12 grid, so that none of our initial numbers are basically on the ending rows. Each of the items will have a corresponding neighbor. And those neighbors, we need to ensure that those neighbors never actually flash. So we can have it like this. So the first row will be an array of, yeah, something like this. The length will be 10, so this will always be 12. And then we will have a grid that we map. So for each row we are adding one item at the beginning and one item at the end. And then again we are adding a full length of zeros. But if we add a zero, that we might increase it. What happens if we increase one of these zeros above 9? Can that happen? I don't think so, because the zeros that are at the corners will always have 3 neighbors exactly, and two of them will be zeros themselves, and the zeros that are not on the corners will have 5 neighbors. And even if all of those 5 neighbors flash, they will get up to 5, and on each step we are recreating the, so to say, the border. And that would mean that this will be safe, I guess. One way to find out. So the fill value will be okay to be a 0. We can always go somewhere at minus 100 or minus 10,000, but I think that 0 will be okay. So now we need to increase everything. Yeah, we can just be brutal. For each row of expanded, for each cell of, now this will just give us the values, we need the indices. We can do a for loop like this, and this is gonna be the row index. We're not doing the array, we're processing the grid, and then the row will be that part of the grid, and then of course we can do a for loop on the column. Not on the array, on the row itself. But of course we can skip the border, so this can be from 1 to length -1. And we can increase all of them. But we can have cascading flashes, and that is a bit of a problem. Now we can obviously do something like this. Grid of actually row of syntax plus equals 1. And this will increase, do the first step of the process. I think I'm gonna need the negative values as well, because what I'm thinking about, so this will be an array of the indexes of the octopi which are full. And I can say now, if not equals 4, but equals is bigger than 9, that is quite okay. In this case, bigger than 9 only means 10 because we're increasing it by 1, and each time we are kind of normalizing it, so it can only be this. So full sposh, not this, but this. I don't like tuples too much, but on the other hand, why not? Now, let's be explicit. We could have this as an object with x and y properties, or we can have it as an array with 0 and 1 properties, where we know that the 0 is the x and the 1 is the y, but it costs about the same, so let's be explicit. So this is what we're gonna do. We have an array of full octopi. Once we're done, we're gonna do, while there are full octopi, well, we will need to flash them. Something like this, only a bit weirder. So we are getting and destructuring one of the octopi. Shift will take the first element, and we're gonna need to set it to something. But I won't be setting it to 0 because 0 is invalid. I will be setting it to something that is really invalid. I'm gonna set it to -100. Because what we don't want to do, if an octopi flashes and that overfills the one next to it, the one next to it will also flash, and it will in turn increase the value of this one. But I want this one to remain as 0. So I'm gonna put it at minus 100. So when it increases, it will get just a bit closer to minus 99. And after I'm done, I'm just gonna say each octopus which has a negative value should have a 0 value. And that's all there is to it. And hopefully it will work. So if you are flashing, you're getting a minus 100. And now I don't need to check anything, I just need to increase the values of all the neighbors. So X and the neighbors are all the items that are offset by 1 in each direction. So that will be plus equals 1, and I will need to check if they are bigger than 9. If they are, add them to the full array, fulls array. So this is something similar. So we're gonna have the same code exactly. And now Copilot is taking over. Let's see. Yeah, that one, and 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 that one we need. And now what? Because it processed all the 4 neighbors that are one off by X and one off by Y, but we need the other ones as well, the other 4. And those 4 will be X plus 1, Y plus 1. X plus 1. Oh, we need to be extra careful here because we have 1, 2, 3, 4. And so we're starting from here. So we have 2 minuses, 2 minuses, 2 minuses. We have a plus and a minus, plus and a minus, plus and a minus. We have a minus and a plus, so this will be minus 1, this will be plus 1, this will be minus 1, this will be plus 1. And I might even have some bugs, so we will need 2 pluses. That will be the last one. Plus 1, plus 1, plus 1, plus 1. Yeah, there is really no better way. Actually, there might be a better way because we can just run a for loop from minus 1 to 1, 2 nested for loops, and have them like that. But it's not gonna get any prettier. 1, 2, 3, 4, 5, 6, 7, 8 code blocks. So if it gets bigger than 9, it can only get bigger than 9 once. So even if it gets blown up a couple of times, it will get, if it gets up to 11 or 20 or whatever, we're just gonna explode it. But we will add it, we could add it multiple times, because if we have one here and 3 nines above it, let's go to the place. This one explodes. If this becomes 9, this one explodes. If this becomes 9, it will be included. This one explodes. This becomes 10, it will be included again. This one explodes. This becomes 11, it gets included again. And we need to blow it just once, otherwise we will increase everything, not by 1 but by 2. So what we will do is just, if the value is less than 0, well, skip it. And since it's minus 100, it doesn't matter how many times it blows, it's just gonna stay negative. it can be theoretically get scheduled 8 different times for each of its neighbors. So it can be 8 times inside the false array, but it will only get run once because we'll set it as minus 100. And from minus 100 you can increase it up to 8 times, it will get minus 92, which is pretty much negative. So we can run another for loop now and just say if row of index is less than 0, row of index is 0. So we're getting it to be a 0. So now we will need to return the grid. Well, we're gonna start from 1 and yeah, exactly this. So we're slicing off the top and the bottom rows, which are our borders. And we're slicing for each row, we're slicing off the first and the last element, which are its borders. So let's see this. Execute a single step and output it. In the first step we won't get any blowups. So after step 1 we should not get this. Are we sure we're having, yeah, 5, 4, 8, 8, 5, 6. This is definitely not what I had in mind. Okay. One thing to check that. Execute step 4 input. Let's debug. What is the input? 548. Okay. 856. Oh, we might have been overzealous a bit. The input is definitely a 10 by 10 matrix, but the one step is an 8 by 8 matrix. We cut off too much. We're cutting from the initial grid. Oh, and we might be working with the initial grid, so we might have a bunch of errors here. So we don't want this. We don't want to mention the grid anywhere. Let's see if I rename this as grid X. Yep, that's wrong because this will need to be expanded. This will need to be expanded, this will need to be expanded, and I don't think I mentioned grid anywhere. And we're working with the expanded thing. And here we do need the grid because we are expanding it. So once again, TypeScript to the rescue because it automatically recognized an unreferenced, undeclared variable. Let's run this one more time. Yeah, just run. So we're getting something. 725. Oh no. 659 and so on. Yay for search. After one step we're getting the exact value that we were supposed to get. So we're getting 659. Okay. one step is okay, but for the first step we didn't get anything to blow. For the second step there will be some blow-ups. Blow-ups happen. Let's see. Because this is what we are actually modeling. Yay! So we got a total match on everything. I just pasted including the enters, and I got a match on everything aside from the formatting. So the text is the same, the formatting is not, which is okay, which is what we want. So it says after step 2, 3, 5, 6, 7, we are running 100 steps. Let's run 100 steps. One hundred grid equals execute step of grid. So we're just reusing the same grid over and over again, and print matrix grid. We're getting something. Yes, after step 100 we are getting the value, and now we need to actually solve the task because we need the number of flashes. How many flashes are there after 100 steps? And I did some thinking and guessing what the second part will be, because I have no idea what the second part is. Basically you need to solve the first part so that you get access to the second part, and I haven't done that. But from what I've seen, these explosions, these flashes, kind of tend to synchronize as each one increases the next one, and we might get a larger section of the octopuses be zero at the same time. So I think that after a certain cycle, we will have a situation when all the octopuses are the zero at the same time, and they're just moving 0 to 9 and then to 0 and back again. And I have a feeling that the second task will be, well, basically simulate this thing until you get an array of zeros and count the flashes. So what we need to do now is to add something to this execute step, because we won't be returning a number array, we will be returning a tuple where we have our grid as the first return thing and our number of flashes as the second, because we needed to actually count them. And that's gonna need to be a number. So now just when we're flashing, and this is the actual flash, we just need to say increase the flashes number, and then where we are turning, return this, and as the second parameter return the flashes. Of course this will need to change where we are using this, so we will just need to say grid flashes equals that. Yeah, total flashes. We can have that, and we need to say that total flashes plus equals flash. We don't need to print this, we need to return total flashes. So let's see for the initial start input, what will we get? 1656. 1656. So if that works, this one we should be totally in the same line, so we just need to execute it and we will get some value that could be correct. 1785. Let's think about that. Let's try that in. Yes, that is correct, as we expected it to be. So it seems like the individual flashes aren't bright enough to navigate. However, you might have a better option. The flash seems to be synchronizing. Yep, told you. In the example above, the first time all octopuses flash simultaneously, it's step 195. So after step 193, now 194, 195 is all zero. What is the first step during which all octopuses flash? So we need to answer 195 to the example. So for part 2, let's use this once more. Only we will need a while true, and we don't need the flashes. This doesn't work, but let's use it. Yeah, we're going to need to increase the index by 1 each time so that we have the correct thing. Let's return to the original input. Is this the original input now? The problem is that the input looks about the same. 548. Yeah, this is the original input. Because we might get the the actual correct value, but go searching for 195. So we need to increase the index, and we need to check whether everything is 0. And since these are from 0 to 9, we can just add them up. Yep. We can use a nested reduce to sum them up. And not bigger than 0, but if it is 0, since we have zeros or positive numbers, this means that, well, everything is 0. So we just need to return the index, because that's the row, the step number that we got. And result for part 2 is 195. We could have a problem here. No, we don't. It's 354. We could have had a problem because it's quite possible. Yep, completed day 11. This is good. It's quite possible to have very similar inputs, but this input, the test input converges quickly to 195, so that's done in the blink of an eye. But to have some kind of a specific tricky input that doesn't converge just as fast, that actually converge much slower. So I'm not sure that that's possible for this specific task, but it's possible for some of the tasks, that basically the input for the example and your actual input look completely the same, but the result for the example is something in the order of hundreds, and the result for your input is something in the order of billions. So if we needed to run through a billion iterations, this algorithm wouldn't have worked. However, it actually ran quite fast. Let's run it properly without debugging and everything to see how fast does it go. It says it's 18 milliseconds for part 1, 24 milliseconds for part 2. Well, notice that the runtime for part 1 is kinda done again for part 2. We could have been able to have a single run through both of them because we're running the first 100 steps 2 times. But that's fine by me because, as I've mentioned a few times, I like my parts to be completely independent so we can solve basically different tasks. We can run them independently. So I know that the time I need to process only part 2 is 24 milliseconds, even if I'm not doing part 1. But I guess the extra time done is basically 6 milliseconds. And still, as we're in the millisecond range and our goal so far is to be a minute, actually, you know what? Let's end this one like that. Let's just run all the tasks that we have up till now. Add 11 and process everything. Let's see if how long we take for the first 11 tasks. We're running with the full input and everything, and I guess we are still have some console logging for task. I'm gonna look from the other side for task 7. Yeah. Yep, we don't need this. Oh, we have another one of those. Let's run it again. Total runtime is about half a second. I'm not counting the time for processing the input, but as you saw, I don't tend to have as little logic as possible in the input processing. That's just the ingestion of the text file. About 40% of our running time is the task number 7, the ones that we actually tried to optimize, I think. But still, it's half a second for the first 11 tasks. Let's get to the tasks that are running for a minute or 2 minutes or 5 minutes or things like that, and then we will try to optimize them. For now, I think this is quite okay. So with 22 stars, I'm gonna say goodbye. See you tomorrow.